يلا بسم الله.
Now, the pyramidal tracts includes corticospinal tract, corticonuclear or corticobulbar tract. The extrapyramidal tracts includes rubrospinal tract, vestibulospinal tract, reticulospinal tract, and tectospinal tract. First, let's see about the pyramidal tract. The pyramidal tract includes the nerve fibers which pass through the pyramid of medulla. This includes corticospinal tract. In corticospinal tract, the nerve fibers arise from the cortex and they descend to the anterior horn cells of the spinal cord. In corticonuclear or corticobulbar tract, what happens is that the nerve fibers start from the motor cortex and they go till the cranial nerve nuclei in various levels of the brainstem. Now here you gotta know the fact that there is no much difference between the corticospinal tract and corticonuclear tract. They both have common origin from the cerebral cortex, the motor cortex, and they both have the same pathway. They both descend together. What happens is corticospinal tract, even though it starts from cortex, they go all the way to the end of the spinal cord. But what happens to the corticonuclear tract is that they start from the cortex, but near they end in the they end in the levels of cranial nerve nuclei. Okay, cranial nerve nuclei. It includes the facial nerve nuclei in the brainstem, the trigeminal nerve nuclei in the brainstem. They end in that level itself. So can note the difference that corticospinal tract is longer than corticonuclear tract, and corticospinal tract basically gives rise to spinal nerves, whereas corticonuclear tract gives rise to cranial nerves. And you also have to know that these two are almost the same, um, in the fact that they have common origin and a common tract, the common pathway by which they descend below. Okay, in this picture you can see this picture is basically to give an overview about the corticospinal tract, because that's the very important thing of the descending tracts. Okay, so the dotted line in the middle shows the midline of the body, and at the top of this picture you can see the motor cortex over there, and from there you can see some blue fibers and red fibers arising from the cortex. That is basically to differentiate the fibers, the tracts. We'll tell you later. Okay, so you can see that the fibers being radiating in a pattern, so that part is known as corona radiata. These fibers descend through the internal capsule, and from the internal capsule they reach the medullary pyramid. From the medullary pyramid, what happens is you can see that the blue line decusates, that is they cross to the other side, opposite side, and they descend below as lateral corticospinal tract, whereas the red line does not cross the midline, whereas they descend down ipsilaterally on the same side to reach the spinal cord. But you can see that after reaching the spinal cord, the anterior corticospinal tract decussates to the other side with the help of an interneuron, and then they supply the muscles. Okay, here you can see that the motor neuron arising from the lateral corticospinal tract supplies the distal muscles, whereas the motor neuron arising from the anterior corticospinal tract supplies proximal muscles. Okay, and you can see that you can note that the blue tract is marked thicker compared to the red tract. Why is that? That's because about 80% of the corticospinal tract decussates to the other side, and that tract is lateral corticospinal tract. Lateral corticospinal tract includes about 80% of the corticospinal tract fibers, whereas anterior corticospinal tract includes only 20% of the fibers of corticospinal tract. And there's also one more point to notice. It's that the lateral corticospinal tract starts from cortex and they go till the end of the spinal cord, whereas the anterior corticospinal tract ends somewhere at the level of mid-thoracic, level. Okay. Now we just summarize it once again. Corticospinal tract is divided into lateral corticospinal tract, which includes 80% of the fibers, anterior corticospinal tract, which includes 20% of the fibers. They arise from the motor cortex of the brain. They pass through the internal capsule and then through the pyramid of medulla. Here you gotta note a point that they do not arise from all parts of the cortex. They arise most commonly from parts like area 4 of cerebral cortex, precentral gyrus, and some fibers also arise from the sensory cortex of the brain. Okay. What is decussation? Where does this occur? The decussation basically occurs below the medullary pyramid. As I told earlier when we were seeing the picture, decussation is basically crossing over. And we have shown you that the blue line, do you remember the blue line which represents the lateral corticospinal tract, which decussated just below the level of medullary pyramid to the opposite side. Okay, so the tract which decussates below the medullary pyramid is the lateral corticospinal tract. You gotta remember this. Now recollect, where does the anterior corticospinal tract decussate? If you remember the picture which we shown you earlier, the anterior corticospinal tract, you got it? Yeah, you got it right. The anterior corticospinal tract decussates at the level of spinal cord. What are the functions of the pyramidal tract? The lateral corticospinal tract is basically involved in skilled movements because they supply the distal group of muscles. The anterior corticospinal tract is basically involved in posture maintenance because they supply the proximal group of muscles. The corticonuclear tract is mostly involved in supplying facial muscles. So here you gotta note the fact that the distal groups of muscles, which are the muscles of hands and feet, are basically involved in doing skillful activities such as you use your hand for writing, for handling stuff like pencils. That requires skill, like those are skillful activities. Those activities are helped by the lateral corticospinal tract. So if your lateral corticospinal tract is affected, your skilled activities are affected. And the anterior corticospinal tract supplies the proximal muscles such as the muscles of thighs, muscles of your arms. So if your anterior corticospinal tract is affected, it most commonly affects your posture. It will be difficult for walking and running and standing straight and all that. Okay. So the corticonuclear tract, as we told, they involve in the facial nerves and the trigeminal nerve. Their motor component supplies the facial muscles. Now let's get into extrapyramidal tracts. As the name suggests, does not pass through the pyramid of medulla. Makes sense, right? Again, these are also involved in posture maintenance as well as doing skilled voluntary activities or movements. Okay. They can arise from red nucleus, vestibular nucleus, reticular nucleus, reticular formation, and the tectum. First, let's see about the rubrospinal tract. The rubrospinal tract arises from red nucleus in the midbrain. Okay, it decussates to the other side, the opposite side. It supplies the distal muscle groups, so it's involved in doing skilled movements. The next one is vestibulospinal tract. Vestibulospinal tract arises from vestibular nuclei. There are basically 4 vestibular nuclei, which include superior, inferior, lateral, and medial vestibular nuclei. They receive input from the inner ear and they help in maintaining the position, the body posture in response to head position. So, as if you know, like I think most of you will be knowing, the inner ear has a cochlear part and a vestibular part. Cochlear part is associated with hearing, vestibular part is associated with balance. Here, as the name suggests, the vestibulospinal tract, this receives input from the vestibule of inner ear. So basically, it involves maintenance of posture. If you all know, the inner ear, the vestibule part is associated with maintaining posture, right? So this basically receives input from the inner ear and it sends information regarding the position of the head and the head position. Okay, and it helps to maintain the body posture according to the head position. Okay, the next one is reticulospinal tract. The reticulospinal tract arises from the reticular formation in pons and from medulla. Okay, there is an ipsilaterally, they don't decussate at all. They supply the proximal group of muscles. As told earlier, proximal group of muscles are involved in posture maintenance. Now let's see about the tectospinal tract. The tectospinal tract arises from tectum or the superior colliculus. It's mostly involved in vision. They decussate to the opposite side.
Let's take a few moments to calm the mind and relax the body.
They are the smallest of all the descending tracts. Okay, so they go up to the mid-cervical level only, and they help in movement of the head according to the visual stimulation. So as I've told you earlier, the superior colliculus is associated with the vision. So when it gets the visual input from the eyes, when they get the visual stimulus, it will help in the movement of the head accordingly and helps in the maintenance of head posture. There's something known as monoaminergic pathways, which is good to know. It includes raphe spinal tract. It is basically serotonergic. It starts from nucleus raphe magnus in the medulla. They inhibits the nociceptive pathways and they help in sensory motor coordination. So basically in this tract, the neurotransmitter which is present is serotonin. The second one is cerebrospinal tract. This is basically in sensory motor coordination. They both start in the tract. You're gonna see they part. Do you remember? Come on. If you can make a list. Okay, don't worry. Repeat the video once again from the first.